Okay. So yeah, thanks for coming, guys. And this is our first AGI salon. So be very nervous, and there's a lot of safety concerns you guys should have right now about what we're about to discover together. We may all be dead by the end of this call, depending how much progress we make. So
Right.
but anyway, I actually put together a website that you guys, some of you guys probably saw in the course of trying to produce more content to get people to fund my research. And in the process, kind of actually discovered a bit about my own research, clarified the actual top level questions. So that was pretty fun. And so now I have those that I can share with you. We can kind of dive into them and see where they go. And I'm kind of curious also to see the broader picture, by the way, for AGI research in my mind is that it's just about knowledge creation in general. So I'm just trying to understand that full spectrum. And so often when you have concerns about visualization, for instance, or you have concerns about causal inference or something else, I think all these things are so intertwined that usually you find interesting things going into the details of one and then trying to see what the generalization of that is and all that sort of thing. So by all means, jump in with your usual interests, because I tend to think that they're pretty fruitful. But yeah, so the 5 questions are basically how do you create new things? How do you take all the things you have created, and assuming that some of them are good, pick the good ones. By the way, for the first question of how do you create new things, it's not enough to create new things. You have to create some of them that are actually good. And that's the part that's not trivial. It's easy to make something new, but something good, not so easy. So that's the fundamental problem there. Then once you have a bunch of things, one of them is good. Which one is that? Then what even are things are we talking about is the third question. What are we subjecting to variation and selection? When you create something new, what is the new thing? What do we even, is it a program? Is it a rock? These things, it depends what you are creating. So those are the first 3 things. Those are sort of the main evolutionary elements. And then the other 2 are sort of attention on the one hand, of all the things you can do, which one do you in fact do? If somebody says something interesting to you, there's a thing in your brain that says, pay attention to that, as opposed to all these other things. And that's also pretty important too, because if you're just randomly bumping around like evolution with no attention, that's a very slow way to go. I'd be like, what should we do next for relativity? And you'd be like, let's look at my cat. Well, it's not really very fruitful use of your existing knowledge to do that. And then the last one is sort of just how do the things actually work in practice? So we have all these high level functions that we want to do. We want to make new things. We want to take the things that we've created and find the good ones. We want to direct our attention to the right place. We want to have powerful things we're creating. But all that is the things you want to achieve. But now how do you take atoms and neurons and things like that and put them together and actually have them compute that OR gate or this thing or some set overlap, some computation you want to do? How do you actually do it? Because there's certain things you might say, we want to do that, but how do you get neurons to do that? It's infeasible to do backpropagation, for instance. How do you get all these differential, take the differentials and all that stuff. So anyway, those are the high level things. I tend to think most everything else sort of falls into one of those things, or is a concern that maybe stretches across all of them. So we have a thing from Ben here. When you look at the cat,
would it be correct to say, Carlos, that number 5 maybe is the one that you are? I have never heard you talk about number 5 implementation. Is that the one that you're maybe less interested in, or number 5?
Yeah, I think one of the things you can say about these 5 things is that some of them get more attention than others. And I think the implementation probably gets a lot of attention from other people. I think there's a pretty wide, one thing you can say about it is that when it comes to computations and how to perform them, lots of people are interested in that question. So I think probably what ends up happening is just taking the best that people have come up with. It's sort of a question here because on the one hand you have these things that are the Popperian elements, the variation and selection things. I think that tends not to be focused on so much directly. Everyone that's making any kind of progress training neural networks is doing some kind of variation and some kind of selection, and they're very interested in the details. But as far as zooming out and seeing those as part of this much broader phenomenon, I think that's somewhat rare. So when it comes to a question like implementation, that's something that people have paid attention to, although there's this question of have the right questions been asked in the context of this variation and selection stuff. basically evolutionary type thinking. Like, has that been applied? Because maybe there's cases where they say, well, yeah, you can do that algorithm, but actually there's this thing that you don't have unless you've been thinking about evolutionary things. And like one question that kind of comes up is like, if you're going to create a new thing, is it going to be like a modification of an existing thing? Or do you, for instance, make a copy of that thing and then you operate on that? So like with DNA, you'd like create a copy of the DNA and either it's a perfect copy or it's not. And so now you have a new thing. Whereas if you said like, I'm going to write on my booklet here, I've taken an existing thing and I've changed it. Like there's no old thing anymore. Now we have a new thing. That's it. And so when it comes to like ideas, you might say like, how do you implement that in the brain? Like, do you like destroy an old thing in the brain? It seems like often you can refer to both things. So how do you do that? And as an example of like that relating to like an existing kind of area of research, you might have seen this as well with like Clojure, programming language, where they talk about like persistent data structures and basically the idea of like you have like a huge array of numbers here, and you want to create a new array, but in the programming language you have this rule where you're like, we don't mutate existing things, we leave them alone so programs that use those things don't get messed up by the fact we changed the thing that they needed. But what they end up doing is they don't create a full-on copy. They just say like, hey, basically the programming equivalent of like, hey, ours is exactly like that thing over there, except we changed the last thing. So that's how they represent it in practice, so that it was efficient. It solved a practical problem, because if you don't do that, it's much slower and takes some more space and this kind of thing. So maybe the brain does something like that, where it's like, conceptually, it can represent two new things, but maybe they share a whole bunch of underlying structure, and that's how it works in practice efficiently. So anyway, I think that's kind of, I don't know if that's right or anything, but that's the kind of thinking that might go into questions of implementation, that number 5 question.
There's another implementation mystery, which is, how does the brain run on so little energy as compared to our computers? What is it, like a 100 watts or whatever it takes to power a light bulb is the sort of energy that our brain is consuming, I don't know, per hour, whatever, but it's nothing. It's a tiny fraction, I think, of what it takes to run computation on any of our hardware. That would point towards an implementation mystery, that I don't know how many people are looking at that seriously. Does that require a whole new architecture? Where does that point you?
That's the kind of question that I wouldn't be able to answer much, other than to say like the book that you guys have been talking about, Arrival of the Fittest, talks about the relevance of catalysis and enzymes and things, and says, here's a reaction we want to achieve, converting chemicals A and chemicals B. And normally, if you want to make that go faster, you have to turn the temperature up. You have to pour energy into the system. But if you have the right enzyme that can just grab them, it can make it 1 trillion times faster without increasing the temperature. So I don't know if that explains the difference between a biological system and an electrical system. That may be an open question. But as far as like taking certain chemical reactions and doing them efficiently, enzymes seem to be like the one-word answer to that. So yeah, like I guess, yeah, I don't know how you would frame the question in terms of comparing it to like logic gates and so on.
I mean, there's research on, I think they call it neurocomputing, and well, I guess we should save it maybe for the next talk. I can pull up some papers, or we can look into it if it seems interesting, and come back to it.
Ben says, I feel. By the way, it's a little bit hard for me to read this on my screen. I don't know if Ben wants to, or one of you guys want to read the messages as they come in. It might help me out here.
I can read it. Ben says, when you look at a cat, it collapses from its superposition of. Oh wait, I'm confused.
I think I see it now. The last message here, the one on the bottom.
Right.
I feel like human cognition seems to be much better directed than its artificial counterparts as well.
Right.
Yeah. That's question number 4 in my little scheme here, I suppose. So attention. Like the way I think of attention is like the use of resources. And yeah, exactly. Like you have so many things you could be thinking about, or not things you could be thinking about. Like you have a certain thing of ideas in your head already. there's a larger space of things that you could think about. All the things you could combine, for instance. You can combine this and that and this in an astronomical number of ways, as they say, more than the number of hydrogen atoms in the universe. But yeah, among the things you have in your head right now, you can select one of them or some group of them and do something with it. And as far as like being directed, you could be like, yeah, confronted a situation now. And ideally, you would use the information about that situation, both of what you see and what you're thinking, to guide what you do next. And if like you bump your head into a wall, and then you're like, now you have an opportunity like to do something different on the basis of that. Like if you were a blind machine and had no sensors there, you might not even realize you'd hit a wall. You would just be like trying to move forward in the X direction, and you'd be like, I'm not moving in the X direction. I don't know what's going on. But a human would immediately recognize that, like, oh yeah, I hit my head on the wall. Now what do I do? And they would be like, well, I probably want to like just logically, I guess you would know, like, I want my head not to touch the wall. So either I can like not go in that direction, or I could lower my head. I can think of in terms of 3D space basically, and how things interact in that 3D space. If you have no notion of 3D space, then that's a very hard operation to do. Like if I told you like actually you're in a 4D space, now even humans would have no idea what to do. You'd be pretty lost as to how to evade this 4-dimensional object that you just ran into. So yeah, in various situations, we have the opportunity to act in a certain way, of one of many ways, and the better we can use the information available to choose among those things, the better off we'll be. And that's the big difference between evolution and us. Although, like when it comes to machine learning, it's a little bit different, since you have like a gradient that you're following. There's some sense of attention there, as well as like the idea that people have for like attention on inputs. So I give you an input, you pay attention to certain parts of that input. That's another form of attention that gets used a lot. Although one thing I would say, and this is like one of the big ticket items for the idea of attention, is that I've been describing like two kinds of attention in a way. Like one, there's the attention on inputs. So there's all the things I see, and if I take all those pixels, I can pay attention to those pixels or those ones. If I'm looking for a pencil, I'm thinking like I want to find this particular pattern in this thing, like a Where's Waldo type thing. So I'm looking in pixel space for a particular kind of thing. But as far as attention on ideas, that's saying like internally. Like I have all these concepts and nouns and things like tables and chairs and this and that. Which one of those is going to get triggered? And which one of those am I going to start investing in and trying to recombine, almost like Lego blocks? So like I have a trillion Lego blocks in my head. Which 5 out of the trillion am I going to take and set aside and start playing with to see which combination solves my problem? Which is a quite different notion of attention from which pixels am I going to look at. But anyway, those are all things that go into how you use the existing resources. And if you do a very poor job of it, you're not going to get there in a million years. And if you do a good job, you'll be done in a second.
Yeah, Carlos, I'm picturing you have on your website one card is comparative epistemology, and you list the 4 categories: humans, animals, AI algorithms, biological evolution. And then you have these 5 questions: generation, selection, representation, attention, implementation. So I'm picturing a 5x4 matrix, where you can kind of, right now we're talking about attention, and I think it's really interesting to compare how does it work in humans, and is there anything like attention going on in biological evolution? I mean, that's just a totally undirected process, and I'm struggling to even come up with, is there attention? Except maybe by a kind of a loose analogy, in terms of the selection process itself. No, I really don't know. So maybe there's zero attention going on in biological evolution.
Well, like one of the things is that like not every spot in the genome is equally likely to be mutated. So there's a certain sense of like attention there. It's pretty loose. It's not very particularly sensitive to the situation. Like if a giraffe needs to be taller in the next generation to like get the fruit in the tree, like there's not really a computation happening to help that happen. But it might be the case that it evolves in such a way that like it's kind of hard to mutate important parts of the genome. And so they're like maybe half as likely or something to mutate. Like I think things like that kind of happen. Like regardless of why or exactly what degree different parts of the genome mutate, like they are different for whatever reason. and changes throughout. And we have a note here on regulatory networks. Are regulatory networks biological attention? Well, I think like
Because
it's interesting to think about different levels of that. Or yeah, go ahead.
no, and this I really like your framing of attention as resource management, because it takes it away from the cognitive context. And I've had such a hard time thinking about attention non-cognitively, or like not always associated with the mind. But if I think about it as research management, I for sure regulatory networks, which in the book on Arrival of the Fittest, he mentions that, right? Which was kind of what you were saying, that they're and they evolve like metabolic pathways, and that's a kind of network. But there's another also interactions which say, okay, now we're this phase when the cellular growth is going to go this way, and then this gets triggered. So that would be the attention management, the research management.
Yeah, like so yeah, the idea that you have a genome with a bunch of genes, but then you can decide when to use each gene, and you can have arbitrarily complicated sort of connections between them. Like you read this gene, and that then tells you to read this gene, and so on. These networks. That is a certain kind of attention in and I think like throughout all these different systems, you sometimes have like different levels of abstraction. You can analyze them, and so it's like in the biosphere, you'd say like the core level would be genes. Then you go up from there like proteins, and then up from there and up from there, and look at different things. In this case, it is interesting to look at that. Like ultimately, it does boil down to like the genes themselves. So like which regulatory networks exist and why will be because of the genes themselves. Like, there won't be like some other layer that tells you what to read and what and so on. So like the particular network of control and all these things is sort of internally defined within the genome. So we can still confine our attention just to that. But I guess it is kind of interesting that you sort of have this idea of like, yeah, you have a genome, and within it, it tells you not only like what each sequence means, like in terms of what proteins to build or what amino acids to use, but then also tells you like where to read itself, which I haven't actually thought that much about. So that's kind of an interesting point.
And I'd imagine there probably are layers above that as well. I mean, just simply portions of the genome that regulate regulators of gene expression. You know, how many layers we don't know.
So it's just like an arbitrary network, I think.
It's
how many levels, you know.
Because my previous metaphor for attention, like the farthest I've been able to operationalize it is like in Turing machines, there's a head, like there's like a cursor, like I'm reading this part of the tape, and I was like, okay, this is attention for me, like that was a concept. But then if I relax it by thinking about resource management, as you propose, yeah, then there are a lot of heads, you know, like reading all the time, cursors. I think of attention as a cursor.
I think the core idea is that there are many options, and you can't choose all of them. That's I think the core idea. And so then once that's the case, or you could say even choosing all of them, like that's a particular use of attention, and it has certain consequences as well. So like if you say like there are 1 million things, and you know at time step 0, at time step 1, the question is, what have you done with those things? Like, has one of them been singled out to affect things, or have you like distributed your effort on all of them? So if I told you like maybe a simpler thing and put it as like, okay, you have 100 projects that you have in your mind that you might want to pursue, which is probably true of all you people. And so you always think you have so many projects you can't decide between them. So you could take the next day and work on all of them for a minute, and you get a certain way forward or whatever. You'd probably be able to remember the name of the project, and then you'd have to close your book and then go to the next one. So you wouldn't make much progress that way, probably. Or you could pick one of them, or you could pick any other number of them. You could switch between them. How you make the decision matters, because if you just work on 100 projects every day, that's probably not going to be very good. And if you have new ideas for projects, this is a really big thing, then now you have this exponential growth where even if you're spending like a minute on each one, now there's not enough time for that. You fill it the whole day. So you have to spend half a minute and then a nanosecond eventually. And so like you can't even do like one logical operation before you need to be moving on to the next one. And so that's the sort of, you know, that's one reason why you need like selection in general, is because like if you have 10 options now and each of those gives you 10 new options after that, then at some point you either use up all your resources and something else is you aren't in control of, is like deciding what happens next, or your resource use like expands exponentially. And even if humans are already expanding exponentially, like the things that we could do expand like even faster exponentially, I think. So like you can never keep pace with all the things you could do. But yeah, I think as far as the attention goes, or this is actually one of the things that is sort of confusing sometimes, is like, is selection the same thing as attention? Is it a special case? Because the way I've described it, it's sort of, I'm not sure. I think the way I'm thinking about it now is that like attention is sort of like at a given moment, there are certain things that already exist, and which one of those you want to attend to next, which one of those you want to deal with, is the question. And then as far as variation goes, that's more of like an over time kind of thing, like a long-term type thing. Like, okay, today you're going to select a few things and then develop some of those, and then onward from there. So it's almost like maybe like a horizontal versus like a vertical sort of view of it. I don't know. I guess it's like through time, I'm going to be dealing with like variation and selection of all these choices. Here's one sliver, and then there's a sliver, and then there's a sliver. I have choices each way, and 10 choices each of those slices. But at this moment, I have all these grid cells I can think of, and I can choose which one of those I want to be thinking about. And they're all available. I can only select some of them or something. There is some deep similarity there between selection in general and attention, but some difference there as well.
But I like it because, to be honest, that has been one of the parts of being a human mind that has been hardest for me, managing my attention. I kind of relate this to mood or something, but there's a sci-fi story by a mathematician, I forget the name right now, but he imagines the first AIs will be like pathologically, they have problems with their attention. Some of them will be like obsessives, and some of them will be like crash and burn, like extremely emotional, which I associate emotion with attention to. It's a kind of resource management. But yeah, because we usually think of AIs as only cognitive, right? But the part of attention, which I guess I'm putting mood here and emotions, yeah, that's hard, and it is a part of cognition. Yeah.
Well, I think like pretty much, I guess this comes down to like that idea of implementation, because like even if you get everything right at a high level, like the way you actually implement it matters. Like if you say like I have an idea for a Turing machine, and you put it out of like tubes and stuff, like that's one kind of machine. And then if you design it as we do now, out of significantly smaller and faster things, that's much better in practice. And then if you have an algorithm equal, I don't know if you know this, but like apparently there's been as much progress in computer hardware or in computer software as in hardware, like for like simulation software and this kinds of things. You can just put side by side, like how have the algorithmic improvements stacked up against the hardware improvements? And you say, well, clearly Moore's law, huge hardware improvements. What about the software? And it's apparently the same or even a little faster in like certain kinds of algorithms. People have come up with more ways to do it faster and better with the same hardware. So there is a question of like, yeah, how you implement this stuff matters. It could be faster or more reliable. And that's one of the other things here too, which is like, yeah, variation, selection, and so on. But like, if the way you've designed it in the brain means that people forget half the stuff, or the electrical stuff isn't working out in such a way that like maybe the brain does something special we don't realize, and it makes you much more stable. And then like maybe if you don't realize that's there and then you don't have it, then you're doing something that makes you go crazy. Like so if we can't really explain, like if we say like, okay, everybody here is human, but then that guy is also crazy and very upset all the time and would wish he wasn't that way, and you don't know why, then you can't necessarily guarantee your AGI that you create won't have be as crazy as that. So I guess that's maybe that's one of those a safety kind of things, but like yeah, like it's hard enough to think about how you would just create a human to begin with, and then when you realize like, oh, there's ways it can go wrong too, like you can get it almost right but then slightly enough wrong where it's terrible for the person and terrible for everybody else. That's a rough consideration. So I definitely haven't given that as much thought, because it's just like, how do you even get the basics down is a big enough mystery. But then like how you actually tune everything so it works well is an interesting question. That's like the AGI safety thing that's like kind of the one that's like about the AGI as opposed to about other people, which is like, when you start creating people, like, are they going to be healthy? that matters. It's not necessarily like we know how to do that yet. Do you like some kind of Greg Egan story?
Yeah. Attention can take place in parallel on multiple levels, right? So you have what you're consciously aware of, that's directing your attention. You have your emotions, sort of less explicit, but it's also coloring what you're aware of, or even if you're asleep, you're dreaming, and that's directing how your resources are being managed. And stepping down further to, say, the cortical column level, you've got hundreds of millions of distinct kinds of computations going on in parallel. That maybe you could, or maybe it would be useful to also say that's a form of sort of local attention. All of it's reverberating, that lower levels feeding up into your emotion and your conscious thought, and it's going down and everywhere in between. That what do you think about that? Does that fit with the way you think about attention, and how does that, and how would selection play into that as well? Maybe it's a way to distinguish the two in a sharper fashion.
Yeah, I think so this is kind of an interesting point that I was thinking about. This may seem like something different maybe, but then comes back to that point. And it's that why does Charles Darwin talk about variation in selection, and Karl Popper talks about like problems, and then sort of variation in selection, and then sort of the cycle? It's like, why does he mention problems? Was it one of the things I thought about? The video is paused due to problems with your network. Are you guys still hearing me?
Yeah,
we can hear you.
Yeah.
The so there was this question I had, like, why is there this difference if Popper is all about evolutionary thinking? Why is it not literally just variation and selection?
Mm-hmm.
Why is there this extra thing? And I think it's that point that you mentioned. It's this thing about attention, which is that what's really fundamental, what you have to have, is the creation of new things and then selection of which ones are the good things. Like, you can't get away from that if you want to have progress in some kind. That's an absolute necessity. However, if you want it to go fast, then you can add attention to it and say, like, okay, well, of all the things I could vary, all the things I could use for selection, I'll use these things and those things. And that'll make things go faster. So at that point, it's again this question of like resource usage and so on, where any way of dealing with, like, any way of saying, like, I want to vary these things as opposed to those things, and I want to use these forms of selection rather than those ones, like anything which that has that sort of behavior counts as a like form of attention. And so problems of the sort that's like, you said X, but that disagrees with Y. Therefore, there's something wrong here, and I need to like think about what that is. Like, that directs your attention. But also, if like you bump your head, that directs your attention. If you just think that's interesting, that's novel, that can direct your attention. So we have like actually like a handful of different kinds of explicit and sort of inexplicit computations happening to guide our attention, where it's like, that's surprising, or that's new, or that doesn't make sense, I'm confused, or like this thing seems to logically disagree with that thing. All of these are distinct computations that are happening. Like, you can't necessarily make one out of the other, but they all have radically different things that they sort of direct you to, like an opportunity in the world. That like, if you start thinking about that, then you might make some progress. So that's kind of why each of these different computations has evolved in our brains. So that comes down to this idea of, it's all just forms of directing your attention, whether that's an explicit thing or it's this more intuitive thing. That's sort of like, they all have that same function.
Right.
But I like that question, Carlos, that you said, that why does Popper mention problems and not Darwin? And I think it also has to do, I think Popper or Deutsch somewhere mentioned that a problem is when two ideas are jarring, right? They're not jiving, they're not, you don't find a way to mesh them. So that's when a problem happens. And so that's why we going to the level of problems is because we're not talking about ideas. And a problem is an idea that doesn't quite match, right? It's kind of like what you were saying.
like the question that I had when that came up was that like is that definition general was kind of my question. Like it seemed a little bit specific, and where do you fit in this picture of like where do the intuitions fall into it? If that's the case, like it's one thing to say like a problem is a disagreement between two ideas, a conflict between two ideas. And then if you say, well, what about when I find something interesting? Well, like, is it possible to express that idea as a conflict of other ideas? Maybe, but it seemed to me more natural to at least zoom out and say like, maybe not. Like maybe that's just a special case. Maybe anything that takes in some information about, from any source about anything, from all your neurons or only two of them or your eyes or anything else, and then says, hey, pay attention to this, and start trying to use that and tweaking that to solve the problem. Like anything that has that basic behavior is what falls into that area of like attention and problems. And so, yeah.
I think so. I do think it makes sense to stretch the concept. In here, I'm influenced by Jeff Hawkins, who has the example of, I don't know, if you go to a door and the handle of the door, if it's slightly like, I don't know, some thief or someone playing a joke on you moves it slightly below, that's going to surprise you, And it is a conflict of ideas. There's a model in your unconsciously, you expect it to be somewhere. Sorry about the noise. You expect it to be somewhere, and that's the collision, that's the conflict. And I'm posing that all sorts of interestingness and attention can be framed as that. Do you think it's too vague?
Well, the thing is, like, it's a logical necessity that it like depend on knowledge in some way. And as far as whether like it's a conflict, that's a particular kind of interaction. So like if I say, here's an idea, now like, so we're sort of assuming that like there's two things in any given situation. Like one of them is like all the things I know, and then there's all the things that like, let's say, define a situation I'm currently in front of, whether that's things I'm seeing or things I'm thinking or whatever. So if I hit my head on the wall, like that's some sensory information. And then here's all the things I know about tables and chairs and walruses and everything else. And so now the idea is like, how will these two interact? If we think in terms of like, here is a statement about physics, and here's another statement about physics, and we can derive things from each of them and see that they're logically inconsistent. That's one kind of interaction, but it's only one kind. An alternative interaction that doesn't necessarily fit into the idea of like that sharp form of like deductive conflict is the idea that like you tell me about flying saucers or something, or just like, or like in the distance I see something sparkle. I'm a caveman. In the distance I see something sparkle, and I know there's no like ocean around here, so or something like that. Let's say, I don't know. Or maybe I'm not even thinking in any of those terms, but like anyway, I see something there, and now it's going to interact with something in my head, all the things I know. It says like maybe that's kind of novel. It's twinkling or whatever, and I'm not used to seeing things twinkle. So as far as like seeing that, like, it's not like a symbolic conflict necessarily, but there's some computation here that says like this thing is not like these things. So there's like similarity and differences being computed, and all that's non-trivial. Like if you put a brick there, it's not going to do that computation. If you put some other system there, it's not going to do that computation. Like that's a very specific computation to be performing. That says I will like see a twinkle. I think that's special, and therefore either like maybe run from it or go to it. Like maybe that's my salvation if I'm starving. It's a different thing. Maybe that's the thing I need. So it should maybe affect my thinking in some way. Or maybe it's like a warship, and I should be getting the hell away from it. So again, it should condition my behavior and have a big impact. I shouldn't just ignore it. So I just think that like when we talk about like the things that define the situation and the things that I know and they're in my head, there's got to be some interaction there. So in terms of that's gotta happen. But as far as like what that interaction is, I think that's open ended. I think it can be anything. It can involve logic or not.
Got it. Yeah, I think I'm a bit of a lumper, but it's valid to make distinctions. But yeah.
So this is like the fun of like the comparative epistemology, to give it fancy term, right? Which is like trying to see like the whole cosmos of this, because like if you start talking about it in terms of like any other system, it might become very awkward to talk about like a conflict of ideas. And even within human things, it's sort of like trying to figure out our intuitions. It becomes maybe a little awkward to frame it as a conflict of any. You start feeling like you're trying to fit in too much into the word conflict. So I think that like trying to zoom out and fit everything into one picture ends up putting you in this mindset of saying, okay, well, yeah, like there's particular ways you could have ideas interact, and like novelty detection is a very interesting and important one that you could imagine evolving way in the past, as well as ideas about prediction. By the way, when it comes to like intuitions and so on, one thing that's interesting to note is that like how different intuitions are. Like that is surprising. You know, so surprise is like a very different computation from novelty, because like expectations, like or like surprise means that you know some things, and then that gives you some expectations about things, and the expectations didn't match this other thing. But if you have like novelty, all you're just saying is like this thing is unlike those things. So it's a different computation here. In a way, you're sort of like saying, well, yeah, I don't know if that makes the full point, but basically, it seems to me like those are two different computations, and I think I read a paper that kind of goes into the detail and tries to like apply both of these different computations to like neural networks, and say like, okay, well, they're different and they're both useful for different reasons. But anyway, I think that like the fact that you have all these different computations going on that serve different purposes, but all or they serve the same purpose in different ways. They try to direct your attention, but by performing different computations that take advantage of regularities in the world, such as that certain things will behave in the same way. Like if you see this, then this should happen. That's a regularity in nature to like causal relationships between like seeing this thing causes that thing. So if you can figure out a way to take advantage of that computationally in your own head, that's good. And then if you can also see like, certain things are different than other things, then if you notice that as well, that's also good for novelty detection. So trying to spout that all out. I don't know if that makes any sense.
I think it does. I think that when we say surprise, that has an kind of an information theoretic definition to it, but that and that's good when we're talking about, you know, a software system. If we're talking about predicting the weather, and you know, we all think it's going to rain, and one weatherman says no, there's going to be a hurricane. You know, that was a bold prediction, and the surprise associated with it. That it's a suitcase word, and I think it kind of does us a disservice, or at least what I like about Popper when he introduces the notion of we start with a problem is it gives us a bucket that makes us distinct from everything else, that makes human generation of knowledge, I would say, distinct. So noticing a problem, I would say, is the unique thing that we do that nothing else does. And it's kind of related to surprise. But I feel like we equivocate. You know, when we are surprised, there's a qualia associated with that. When Chat GPT is surprised, well, it's not surprised. It's, you know, but I know that there is a notion of surprise that is information theoretic, and that's fine. That's some math that probably has nothing to do with how we think.
Well, like the way I think about this stuff is something like, well, so I think surprise can be rescued from like a totally arbitrary type thing. Like, I think like in the simplest case, you just say like A follows B, and so anytime anything triggers A in your head, then you say, okay, I'm pretty sure I'm about to see a B, and then like either you do or you don't. And you have a method of testing that, of like saying, like recognizing whether you did see the B or you didn't see the B. And so if you have a whole bunch of these A's and B's in your head, then you have a whole bunch of these things that are checking all that stuff all the time. That's a very specific kind of computation. And it's not trying to say like, it's not really about bits necessarily or anything information theoretic, and nor is it about intuition, or it's not about qualia either. And it's also radically different from saying like, I have a bunch of A's, B's, and C's over here. Is this one of them, or is it a D?
Mm-hmm.
So I think you can just draw, you know, circles. Maybe I should do like Ellie said and have some visual aids to
Yeah.
kind of think about that.
how about surprises as contradiction or contrast with expectation, and novelty is more like expansion, you know, like you acquire a new expectation, but like you expand your map, you know, sort of like.
So I think that the relevance of like novelty detection might be so that you can do that. Yeah. So it's not that you have done it, but it's like saying like yeah, like if you have some inbuilt ability to like then like expand your knowledge somehow, then there's a question of like when you deploy that, because presumably it's costly to do it, so you shouldn't do it all the time. And like also it might be that so yeah, anyway, so you have this particular behavior you might have to like acquire some image of like some new animal or some new plant, and be able to like recognize that it is a new thing, then allows you to go into that behavior and so on. And then if like with all these things, this I should probably put this as like a general rule somewhere, but like, you know, like with everything that humans do, like one of the big questions to ask is not only like how it compares to other things, like what would happen if we didn't do that thing? Like, what would happen if we had no capacity for surprise or attention or these other things? Just ask like what then? And usually what happens is something terrible.
Yeah.
Suddenly you just become exponentially worse at all kinds of things, where it's like you suddenly would bump your head and you wouldn't know what to do. You just keep doing it. That'd be the kind of behavior you would end up with usually.
Yeah, that's pretty cool. I almost, you know, maybe it's another page on your website or a tweet thread, which is, what if we stripped away attention or some subpart of attention? What if we stripped away, some of them are more obvious, if we stripped away generation, but I like thinking about it. Delete something within a human. Now what does that look like? How do things fall apart? Do you just die instantly, or you know, how do things go wrong?
Usually not, because like everything we're talking about is like epistemological. So like it sort of assumes that you have a bunch of things that already work, that you have a bunch of knowledge that's already built up. Now what we're messing with is your ability to create new knowledge. So it's only to the extent that you depend on creating new knowledge that you end up having a problem. To the extent that you're just relying on automated stuff already that you've got in your head, you're fine. But like that's kind of like the thing with DNA. You can actually delete all your DNA and you won't die instantly. You'll die very soon thereafter.
Well,
Yeah.
but I'm thinking like if you delete generation, now you're just stuck with the knowledge you've built up, and you know, maybe you can go for the rest of your life. It's just you seem like a dull person. If you delete selection, then you're generating stuff and you're not selecting, and maybe your brain fills up, and you know, seconds later you run out of oxygen and blood, and you know, that's it. So yeah, it may be. It's harder to think about how do I delete representation. You can't really delete representation.
Oh, well, I mean, yeah, like you just wipe out all the bits, or you like start making certain kinds of things inexpressible. That's a big problem.
Or taking out your visual imagination, or taking out your face recognition, maybe, you know, or taking out your verbal expression. Right. But hey, guys, I'm a bit more of an adder. I like to add stuff, and like all this talk about surprise made me think about a cat that we had that has now died. But anyway, he lost one of her feet, so we called her Tripod. This cat. But my point is that as she moved, as he moved, because she was a very agile Badger cat, her motion systems took account into that he didn't have a leg, so it was fluid. But I always kept wondering, like, regret is a kind of surprise, you know, like I just imagine if I lost a hand, like I would always be I will always be contrasting this, like, oh, my hand is not here, and I feel that cat was spared that problem, right? Or do you think that cats are capable of thinking about that kind of thing?
I don't think so. I think regret is a way to there you have in your mind representations of how to use this arm and when to use the arm, and regret is almost a way to delete those things. Or when you mourn the loss of a loved one and you feel grief, but then over time that sort of fades. It's you have a thought, I want to tell this person something. There was good news in my life. Normally I would call, and I kind of think of the emotion as that, recognizing that there's something there that not that it needs to be deleted, but it needs to be wrapped in a new wrapping, and to stop asking for something.
It's so funny that you thought of that, because so what happened soon after the cat lost? Well, he lasted for like 2 years, but then he died because he was too adventurous, and her sister always kept meowing, like looking for him. And so my parents, when he died, they took his body and showed it to her sister, and I was like, do they really? Can they tell? They're like, like.
Yeah.
I didn't expect that. I thought you were gonna say something like she lost her leg, and then I was like, they can't grow back, can they? And then you're like, no, it's okay, she died. I was like, oh, okay. And then they showed it to the other. I was like, man, this is quite several turns here. That's interesting.
Well,
but it's related. So it's a kind of regret, and so people. I've talked to several people who have cats, and they swear that they can tell about the mourning that is regret. They swear that kind of thing they can process, they can compute. But the one about like the longing for the lost arm, that seems to be beyond them.
Like one thing that's kind of an interesting question that's pretty general is this cultural or is this built in? Is this sort of parochial and like you could have it or not? Like it's kind of a thing that people have come up with in the course of history, or is it something that evolved? That's maybe the more fundamental question. Is it something that has evolved, or is it something that has been invented? And when it comes to like good explanations, for instance, that David talks about, that's maybe something that we've invented. But when it comes to like something like surprise, I'm guessing the mechanisms for that, kind of like with vision, are also pretty finely tuned, and so those evolved. And you could maybe see an argument as to why they would be useful to many species throughout like evolutionary history. Like regret, I don't know which category it falls into, but like you could maybe imagine, and maybe it's almost like Freudian, like we're just inventing reasons for things to exist, like, and maybe it's just all made up, but you can certainly imagine that like just as you might want to take it, recognize novel things or recognize surprising things, and you might also want to have things in the past that remain important to you, that continue to affect your thinking. If like you live in a village and everybody that you know got killed because you made the wrong decision, that's maybe something that you ought to affect your thinking, and like
whoa, it's so dark.
What's that?
So dark. Sorry.
That's evolution, baby. But like that's like David made that point, right? Like if you feel pain for anything, or like basically all the feelings that you have, like you have them because all the guys that didn't have those like got killed, and they kept getting killed, and the ones that kept having it kept getting killed less than the other ones. So like all the things that we owe, all our capacities, like if evolution didn't call them out, then all the things that like didn't have those special capacities would have been equally good at surviving. So the fact that like we all these advanced features is because like they were actually pretty necessary and useful. So
right.
But yeah. So anyway, like you could imagine it being the case that certain things ought to stick in your mind and affect your future behavior more than others. Just as a general point, like one question is like, do you even remember it? Like, so does it go from short-term to long-term memory? That's one kind of question. But then even after that, there's sort of that question that you mentioned earlier about like genes and networks and so on. Like you can have a gene and not use it. But then if you have another gene that says, oh, I'm regulating that gene and saying use that gene a lot, that's a different way of using the gene. And, so there's a difference between having something and then using it in general. And so you can imagine it being the case that like regret maybe helps, is like one way of tuning that and saying, okay, like, you have a bunch of things in your head now, but this one is awfully important, so you probably ought to revisit that next time you go hunting or whatever it is. And that one ought to stick in your mind. Yeah. This is a part of like another general thing that I don't know if it sort of comes into attention. Maybe it's just a different way of saying attention, which is like the use of knowledge, which Hayek had this paper, the use of knowledge in society. Like reading that, I thought that's kind of a nice phrase. So you just lop off the last 2 words and just talk about the use of knowledge in general. So I think in that case, it's again saying like, okay, you have the knowledge, but now how do you use it? Because it's no good having it if you can't use it. Like what is it that David said, like if you can't reliably store and retrieve the information, then it's not really stored in a sense that matters. So that's pretty important too. Yeah. Does that have we covered all the 5 areas?
We've touched on all of them, and I actually was thinking, wouldn't it be cool if you had a thread on each one of the 5 questions? So, generation is an original post, and then you just keep adding to that, stuff that you've had from the past or new insights from these conversations. And of course, these threads would be intertwined. So at some point, attention would make its way into selection, but it might be kind of fun to follow, if these categories persist. I think they will, these 5 questions. It might be kind of fun to see the thread of threads on each one. And so there's that. And I would like I'm going to at least think in terms of the matrix of human animal, the comparative epistemology categories and the 5 questions, and doing pairwise comparisons. And then today, when you say let's delete things, just within humans, and when Ellie says I like to add things, now I've got 2 other things to think about. Delete. What if we delete? What if we add just within the category of human? So that's my.
But it has like I think it has an official name. It's called like lesion analysis or something.
Oh yeah,
like brain lesion. I think when
you mean studying the brain, yeah.
Like a lot of like neural network papers will do this, I think, as well. They'll be like, hey, we produced this new architecture that has 3 or 4 different features to it. Let's actually, at the end of the paper, once we've said like it works well, maybe better than everything else, let's like delete all the like one by one each of the 4 things and see like, which one of them made a difference. Like, could you have done all of this if you rip this part out? Like, did it matter? So it's actually pretty like common and important thing to be like, okay, well, if you submit a whole bunch of ideas, which one of them actually matters? So I think did over this analysis. I think it maybe originally came from like brain lesions, where it was like, people studied when people had missed like this part of their brain and saw what happened.
Right. Yeah. Right.
I gotta say that I also like the 5 questions. I think they're good. They're really good. And I gotta say that by far I'm most fascinated with the number 3, the representation, because there's this thing about like I forget where I read this, but it stuck with me, which is like, what is the difference between a problem and a solution? Because often, like especially like in math, what you do is like transform the representation into a way that it now becomes obvious to you. But in a way, it's what did you do? You only like rotated the representation. And I'm just fascinated by the question number 3.
Yeah.
If I don't know how much time you guys have, we can talk a little bit about it, leave it for next time. Up to you guys.
Great, sounds good for next time. Yeah, but this is really nice. I don't know about you guys, but I have fun. This is fun.
Yeah. Oh, totally.
For next time, or to talk a little bit about now. I think my audio cut out there.
I'm up for next time.
Let's save it for next time, I think. Yeah.
Right.
Cool. Yeah. Well, I shall give you a salute, and we none of us died, despite hopefully making some progress in AGI. So glad we could do it.
Yeah, thanks for inviting me. Sorry I wasn't able to participate as much this time.
Awesome.
No worries. You sent in a few few typed questions. That was fun. I think there was a cat in there, so all good.
That's right.
See you guys.
Well, we'll sign off then.
Bye.
Adios.